Good morning everyone. In our last lecture we derived or we state the law of conservation of angular momentum and derive its expression, that is I omega equal to constant. So up to last lecture we have completed the number of physical quantities which are required to study the rotational dynamics of body, starting from moment of inertia, radius of gyration, torque acting on rotating body, kinetic energy of rotating body, kinetic energy of rolling body. Then we obtain expression for angular momentum of rotating body, and yesterday last lecture we have seen or we study the law of conservation of angular momentum. Now there are some another articles given in this chapter. So these are theorems or principle of number one parallel axis and second is perpendicular axis, and then we have to obtain moment of inertia of few regular bodies and application of these principles or theorem of parallel and perpendicular axis. This is again a very important part as far as the rotational dynamics is concerned. There may be question for at least 3 marks on each of these articles and their applications. Number of numerical problems you have to solve on the application. So this article is very important. You must understand this article very clearly. So first part here, principle or theorem of parallel axis, and then we will study the principle of perpendicular axis. So first, see here, this is a rigid body. There are two axes, one passing through point C and second axis passing through point O. As you can observe, these two axes are parallel to each other. They are separated by small distance h. So these things must be clear to explain the figure. So how we can explain the diagram or figure? Consider a rigid body first rotating about the axis passing through point C, where C is center of mass of the body. Consider another axis passing through point O. These two axes are parallel to each other and they are separated by small distance h. Now we have to consider a particle of mass dm which is kept at point D. It is small particle of mass dm. There are such number of particles, element mass in this body which are situated throughout the body. Each element mass is dm. One such mass is considered at point capital D. Now we have to complete the figure. Join OD, CD and draw DN perpendicular on OC produced. OC ला प्रोड्यूस करा आणि त्याच्यावर DN परपेंडिक्युलर टाका. काय काय गृहीत धरलं आपण फिगर मध्ये? एक रिजिड बॉडी आहे. त्या रिजिड बॉडी मध्ये एक ऍक्सिस सेंटर ऑफ मास मधून जातो, दुसरा पॅरलल ऍक्सिस आहे तो O पॉइंट मधून जातो. दोन्ही ऍक्सिस एकमेकांपासून h इतक्या अंतरावर आहे. एक छोटस इलेमेंट मास गृहीत धरलं dm, जे की D पॉइंटला आहे. आता फिगर कंप्लीट करायची. O पासून D पॉइंटला जॉईन केलं, C पासून D पॉइंटला जॉईन केलं आणि D पासून E वर एक परपेंडिक्युलर टाकली, जी की OC ला प्रोड्यूस केल्यानंतर त्याच्यावर परपेंडिक्युलर पडली. हे झाले फिगरचं एक्सप्लेनेशन. अगोदर आपण हा थिअरम प्रूव्ह करूयात आणि नंतर त्याला स्टेट करूयात, मांडूयात. सो अगोदर तुम्ही वाटलं तर अगोदर आपण मांडू सुद्धा शकतो, तो काही हरकत नाही. याचं स्टेटमेंट अगोदर मांडायचं, बघा कसं करणार. याचं स्टेटमेंट जे आपल्याला प्रूव्ह करायचं आहे, IO equal to IC plus capital M आणि small r square. किंवा h स्क्वेअर. ह्याला मांडायचं कसं बघा. अगोदर याच्यातला प्रत्येक गोष्ट लक्षात घ्या. आय म्हणजे मोमेंट ऑफ इनर्शिया. ओ म्हणजे कोणत्या ॲक्सिस भोवतीचा? ओ ॲक्सिस भोवतीचा. आय सी म्हणजे मोमेंट ऑफ इनर्शिया ऑफ दिस बॉडी अबाउट द ॲक्सिस पासिंग थ्रू सेंटर ऑफ मास. कॅपिटल एन टोटल मास ऑफ द बॉडी. एच it is distance between two parallel axes. See here carefully. Here is product of mass of the body and square of the distance between two parallel axes. How you have to state the law or principle of parallel axes? See here carefully. These terms must be clear. Name of each term. IO is moment of inertia of the body about any axis. Here it is passing through point O. Second, IC, it is moment of inertia of the body about the axis passing through center of mass. Then here is product of M is mass of the body and H is square of distance between two parallel axes. Now see here the statement. How we can state the principle of parallel axis or theorem of parallel axis? Moment of inertia of any body about any axis is equal to the sum of its moment of inertia about the axis passing through center of mass and product of mass of the body and square of the distance between two parallel axes. This is the statement. How we can state? Just we have to read this equation. So statement of theorem of parallel axis or principle of parallel axis, it may give you 1 mark statement. So principle states that moment of inertia of any body about any axis is equal to sum of its moment of inertia about the parallel axis passing through center of mass of the body and product of mass of the body and square of the distance between two parallel axes. So this is the statement of principle of parallel axis. Once again, so moment of inertia of any rigid body about any axis is equal to the sum of its moment of inertia about the parallel axis passing through center of mass of the body and product of mass of the body and square of the distance between two parallel axes. So this is statement. We have to prove this statement. So here we consider the figure, explanation of the figure. Now the mathematical part. Once again explanation. Consider a rigid body rotating about the axis passing through center of mass. Let any another axis passing through point O, parallel axis passing through point O, which is a distance S from the center of mass. Let a small element of mass dm placed at point D join OD, CD and draw DN perpendicular on OC produced. Now we have to obtain the theorem proof of this theorem. So the moment of inertia of this element mass dm, Mi of element mass dm about the axis passing through center of mass, it is IC, is equal to integration of dm into distance square, it is CD square, or you can write this as CD square into dm. This is moment of inertia of the element mass, just element mass, moment of inertia of the element mass about the axis passing through center is CD square into dm, R square into dm. Moment of inertia of total body, therefore IC equal to total body. For total body moment of inertia equal to integration of CD square into dm. Consider this as equation number 1. Similarly, we can write moment of inertia of this element mass about the axis passing through point O. It is dm into OD square. We can write moment of inertia of total body about the axis passing through point O. So IO equal to integration of OD square into dm. Call this as equation number 2. This is moment of inertia of total body. This was moment of inertia of only element mass. This is moment of inertia of total body. One thing must be clear, when we take integration, it is for total body. When we are not using integration, means it is for only element mass. For dm, about center of mass IC equal to CD square into dm, distance square into mass, element mass. For total body, it is integration. For total body, about the axis passing through point O. Now, in figure, see here in triangle. In triangle OND, use Pythagoras theorem. OD square equal to, what is ON square plus ND square. What is ON? How we can write ON? It is OC plus CN. There. This OD square equal to, in bracket, it is OC plus CN bracket square plus N into D square. Expand this. So OD square can be written as, it is OC square plus 2 OC into Cn plus Cn square plus Nd square. See here carefully. Cn square plus Nd square, it is Cd square. So finally you can write this OD square equal to OC square plus 2OC into Cn plus, instead of Cn square plus Nd square in this triangle using Pythagoras theorem we get, it is CD square. So you can write this as CD square. Now use this value in equation 2. Using in equation number 2. See here carefully. So IO equal to integration of, instead of OD square is total term, it is OC square plus, we can write this CD square plus 2OC into Cn into total element mass dm multiplied by dm. Now multiply separately by dm to each term and take integration also separately. So here you can write IO equal to, first integration of OC square into dm plus integration of CD square into dm plus the integration of 2 OC into Cn into dm. See now carefully. From equation 1, integration of CD square into dm, instead of CD square into dm we can write IC. OC equal to, what is OC? OC equal to H. Put, we can write here, put OC equal to H, integration of CD square into dm equal to IC in this equation. Therefore, we can write IO equal to, here instead of OC square into dm, instead of OC we can write H. So it is H square into dm plus, instead of CD square into dm it is IC plus, here again integration of 2 OC is H into Cn into dm. Just adjustment of terms. So So IO equal to this IC plus this H is constant, take it outside the integration. So here H square into integration of dm, here again 2H is constant, integration of Cn into dm. But integration of dm is one small element. There are such number of elements which will reduce total mass of the body. So integration of dm means collection of mass, collection of element mass. So collection of element mass means total mass of the body. There, but integration of dm is equal to capital M, and integration of Cn into dm is equal to 0. As the Cn is distance of n from point C, actually there is no mass, it is a part of center of mass. So the moment of mass about center of mass is always 0. Product of mass and perpendicular distance, it is moment of mass about center of mass. This dm is a part of center of mass, therefore moment of mass about center of mass equal to 0. So writing these two, we can write the final expression is IO is equal to, here is IC. Instead of dm, integration of dm is m, so it is capital M into H square. So this is the statement of parallel axis theorem. IO equal to IC plus m H square. How we can state once again? Moment of inertia of rigid body about any axis is equal to sum of its moment of inertia about the parallel axis passing through center of mass, and product of mass of the body and square of the distance between two parallel axes. So this is statement and proof. So हे झालं पूर्ण एक्सप्लेनेशन. फिगरचं एक्सप्लेनेशन कसं केलं? एक रिजिड बॉडी आहे जी की सेंटर ऑफ मास मधून गेलेल्या ॲक्सिस भोवती फिरते. दुसरा एक ॲक्सिस घेतला ओ पॉइंट मधून जाणारा, जे पहिल्यापासून एच इतक्या अंतरावर आहे. एक छोटंसं इलेमेंट मास घेतलं डीएम, डी पॉइंटला ठेवलं, त्या डी पॉइंटला जॉईंट केलं ओ पासून सी पासून, आणि डी एन एक परपेंडिक्युलर टाकली ओ सीला प्रोड्यूस केल्यानंतर त्याच्यावर स्टेटमेंट तयार केलं होतं आपण. आता मॅथमॅटिकल पार्ट बघायचा. हे छोटेसे इलेमेंट मासचं मोमेंट ऑफ इनर्शिया सेंटर मधून गेलेल्या ॲक्सिस भोवती लिहू शकता IC इक्वल टू CD स्क्वेअर, अंतराचा वर्ग गुणिले इलेमेंट मास DM. पण आपल्याला ते इलेमेंट मासचा नाही पाहिजे, पूर्ण बॉडीचं पाहिजे. सो पूर्ण बॉडीचं मोमेंट ऑफ इनर्शिया अबाउट द ॲक्सिस पासिंग थ्रू पॉइंट C, दॅट इज सेंटर ऑफ मास, इज IC इक्वल टू इंटिग्रेशन ऑफ CD स्क्वेअर DM. त्याला इक्वेशन नंबर 1 म्हटलं. तशाच पद्धतीनं ओ पासून गेलेल्या, ओ मधून गेलेल्या ॲक्सिस भोवतीचा अंतराचा वर्ग आणि मास टोटल बॉडीचा. सो IO इक्वल टू इथं इंटिग्रेशन ऑफ OD स्क्वेअर, इंटिग्रेशन ऑफ OD स्क्वेअर इंटू DM. जॉमेट्रिकल पार्ट फिगर मधला बघायचा. इथे एक ट्रायंगल दिसतो OND, याच्यामध्ये पायथागोरसचा थिअरम वापरला. OD स्क्वेअर इक्वल टू बेस ON स्क्वेअर प्लस ND स्क्वेअर. पण ON हे दोन भागात आहे, OC प्लस CN ब्रॅकेटमध्ये टाकलं, त्याला एक्सपांड केलं आणि ही किंमत आणली. आलेली किंमत परत इक्वेशन 2 मध्ये ठेवली. इंटिग्रेशन सेपरेट घेतलं, प्रत्येकाला DM ने गुणाकार केला. OC स्क्वेअर इंटू DM, इंटिग्रेशन ऑफ CD स्क्वेअर इंटू DM, इंटिग्रेशन ऑफ 2OC CN DM. पण इंटिग्रेशन ऑफ OC स्क्वेअर DM बरोबर आहे IC इक्वेशन नंबर 1 प्रमाणे, आणि OC बरोबर आहे H. O पासून C पर्यंतचं अंतर म्हणजे पॅरलल ॲक्सिस मधलं अंतर. त्या किमती ठेवल्या. फायनली असं लक्षात येते की इंटिग्रेशन ऑफ DM टोटल कलेक्शन ऑफ मास म्हणजे कॅपिटल M, आणि इंटिग्रेशन ऑफ CN इंटू DM, CN हे अंतर आहे N पॉईंटचं C पासूनचं, आणि त्याला इलेमेंट मासने गुणाकार केला. ॲक्च्युली सेंटर ऑफ मास आहे C ला, टोटल मास तिथं कॉन्सन्ट्रेट झालेलं असतं, त्याच्यामुळे मोमेंट ऑफ मास अबाउट सेंटर ऑफ मास इक्वल टू येत असतो 0. So CN into DM equal to 0. Therefore IO equal to IC plus M into H square. So this is moment of inertia of rigid body about any axis equal to sum of its moment of inertia about the axis, parallel axis passing through center of mass, product of mass of the body and square of the distance between two parallel axes. हे झालं त्याचं स्टेटमेंट. आता अशाच पद्धतीने आपल्याला प्रूव्ह करायचा परपेंडिक्युलर ॲक्सिस, तो आपण नंतरच्या तासामध्ये बघूया.